All right, so this is part 4 of solving a system of linear equations. And basically, we're going to title this Putting It All Together. So you'll be given a system, you want to determine, and you have your choice. It does not matter which method you use, whether you use substitution or whether you use the addition method. It does not matter. But sometimes the way the system is expressed tend to help us determine which one's more efficient. So for example, if you look at y equals x minus 5 and then 2x minus 5y equal 1, for me, this system would be easier to solve just by using substitution because y is already by itself. So since y is by itself, remember the substitution method, then make sure you go back and using the notes from this section. But the substitution method says that I'm going to solve one of these equations for one of the variables, which this one already is. Okay, then I'm going to take this equation. So I'm going to take y equals x minus 5, and I'm going to substitute it into that other equation in place of y, because that's what y equals. All right. So then I'm going to take this and substitute it into the other equation. So now my equation becomes, so now we get 2x minus 5 times y, and I'm going to put that in parentheses, and y, remember, is this right here, x minus 5, close parentheses, and that's going to equal 1. So now I have this new equation, this linear equation, with the variable x, and I just solve for x. So then we're going to solve. So distributing the negative 5, I get 2x minus 5x, and then negative 5 times negative 5 is a positive 25, equal 1. Combine like terms, 2x minus 5x is a negative 3x plus 25 equal 1. Subtracting 25 from both sides. Combine like terms, I get negative 3x equals a negative 24. And then getting x by itself, right now I'm multiplying by negative 3. The opposite is to divide by negative 3. So I have to divide both sides by negative 3. And so negative 3 divided by negative 3 is 1. 1 times x is x. And a negative divided by negative is a positive. And 24 divided by 3 is 8. So for my solution, and we're going to write as an ordered pair, my solution will be 8 comma, and we just got to figure out what the y coordinate is. So to figure out the y coordinate, you're going to back substitute. And you go back into one of these equations, or you can remember if y was an array by itself, then at this point you would get the variable by itself, whether it's y or x. But you're going to go to one of these, or the one you did in step 1, and where we see the variable x, you're going to plug in 8. So it's easy to use this one because y is already by itself. So we're going to back substitute. So now I'm going to substitute. So basically I'm going to substitute x equal 8 into y equals x minus 5. And so I get y equals x, which I'm saying is 8, subtract 5. And so therefore my y value is 3, because 8 subtract 5 is 3. So there's my solution. All right. Now, let's kind of review something as well. So remember, we talked about, in the first part, we talked about the fact that when we talked about graphing, that the fact that if the two lines intersect at one point, we talked about what happens if the lines are parallel, and then we talked about the fact that if the lines coincide. Okay, so for this one right here, if the lines are parallel, remember when solving a system, your solutions are where the two graphs intersect. So this one's easy because the lines don't intersect, so there are no solutions. So that's called an inconsistent system. So an inconsistent system is a linear system with no solution. Okay? All right. And then so a consistent system is a linear system that has at least one solution. Okay, it says at least. That's the definition of a consistent system. So if you look at this right here, this linear system has one solution because they only intersect in one place. This linear system, remember, they coincide, so there's an infinite number of solutions. All these points on that line are solutions, and there are an infinite number of them. So both of those are consistent systems. Both of those are consistent systems, okay, because they have at least, right here, they have at least one solution, okay, but if it has an infinite number, not only is it consistent, but it is also dependent. So each equation is dependent upon the other. They were technically when you graphed them, they were the same graph. Okay, so consistent, inconsistent, no solution, consistent, but we also say the two lines are dependent. So it's a dependent system. Okay, all right. So going back over here, there's only one solution. So this system right here is a consistent system. So since there's only one solution, the system is consistent. Now remember what that means is that if it only has one solution, it means that the graphs, if you were to graph the lines, they intersect, since there's only one solution, they intersect at one point. So they intersect at 8, 3. That's what that means, because that's your solution. That's where they would intersect. Okay? All right, let's look at number 2. All right, number 2, you have, let's say, 2x minus 3y equals negative 13. And then 5x minus 12y equal negative 46. All right, so notice that in this system, the lines are both in standard form, and notice the x's are aligned, the y's are aligned, and the constants are aligned, and the equal signs are aligned. Okay. Now I would not solve this one by substitution, because none of the variables by themselves, and none of the variables have a coefficient of 1. And you may say, well, I can divide this by 2 and I'd get a coefficient of 1. Yeah, but you would also end up with fractions, negative 3 halves, negative 13 halves. And you don't want to deal with fractions if you don't have to. So the addition method would be the most appropriate method to use here. All right, so let's see what we do. So remember, when using the addition method, you have to eliminate one of the variables. It does not matter which one you eliminate. It does not matter. So I'm going to just go ahead and eliminate the x's. So let's eliminate the x's. So you got to pick one of the variables. It does not matter. All right, so I'm going to eliminate the x. Now to eliminate the x, we've got to find the LCD of the coefficients of the x's. So the LCD of 2 and 5 is 10. All right, now I'm going to rewrite this and listen to the words I'm saying. All right, so I'm just going to go ahead and rewrite this. Now remember, to eliminate the x's, the coefficients have to be opposites of each other. Okay, they have to be opposites. So for example, if I want this to be a positive 10, then I need this to be a negative 10. If I want this to be a positive 10, then I need this to be a negative 10. Because 10 and negative 10 cancel out. That's 0 when you add them up. All right, so you just got to determine which one you want to be negative. It does not matter. So let's just make this one negative. All right, so if I want, and put all those in parentheses. All right, if I want this to be a negative 10, then I've got to multiply both sides of this equation by a negative 5, because a negative 5 times 2x is a negative 10. Okay, if I want this to be a positive 10, then, so this is negative 10, this has to be a positive 10, then 2 times 5x is going to be 10x. All right, now remember, you are multiplying both sides of these equations, of this first equation by negative 5, and you're multiplying both sides of this equation here by 2. All right, so remember, you're going to distribute here. Okay, everything has to be multiplied by 2. Okay, so now let's see what we get. All right, so we're going to get negative 5 times 2x is negative 10x. Negative 5 times negative 3 is a positive 15y. Negative 5 times a negative 13 is a positive. Negative times a negative is a positive 13 times 5 is 65. All right, and always double check. If you do that in your head, be careful, double check. All right, 65. All right, next one. 2 times 5x is 10x. 2 times a negative 12y is a negative 24y, equal, and then a positive 2 times a negative 46 is a negative 92. All right, so negative 92. All right, so now I'm going to add. So when I add, the variable x of terms x's becomes 0. And so I get 15y, and a negative 24y is a negative 9y, equal 65, and a negative 92 equals a negative 27. And then dividing both sides by negative 9. Negative 9 divided by negative 9 is 1. 1 times y is y. I get y to be positive 3. Okay? Alright, so that's y. Now, to find, so far my solution, the ordered pair, so y is 3. So now we're going to find x. So we're going to back substitute. We're going to back substitute to find x. It does not matter which equation you use. But wherever you see the variable y, you're going to plug in 3. Again, it does not matter which one you use. I'm just going to go ahead and use the top one. So now we got to find x. We got to find x. So I'm going to use top equation. Okay. So here's what we're going to. I'm just going to go ahead and rewrite it. 2x minus 3y equal negative 13. So many places, if you're not careful, where you could make some kind of error and then the whole solution would be incorrect. But you should, if these are nice numbers right here, you should always check your solutions or your proposed solution, which you think are your solutions. Alright, so I get 2x minus 3 times y is 3, equals negative 13. So I get 2x, a negative 3 times a positive 3 is a negative 9, equals negative 13. Adding 9 to both sides and combine like terms, I get 2x equal, that's a negative 4. Divide both sides by 2, I get x to be a negative 2. So there's your x coordinate, and then voila, you're done. All right, so that was elimination, or we call it the addition method. And again, just plug your x and y in to verify that this side does equal negative 13, and to verify that this side does equal negative 46. All right, so for example, if you check, remember you're checking negative 2, 3. So if you do the top equation, so x is negative 2, y is 3, so 2 times negative 2 minus 3 times 3, and the question is that equal to negative 13? Well, that's a negative 4 plus, and that's a negative 9, and negative 4 plus negative 9 is equal to negative 13. The other equation, you got to check both of them now. So there's my other equation. So in place of x, I plug in negative 2. In place of y, I plug in 3. So 5 times negative 2 minus 12 times 3. And I want to see if that's equal to a negative 46. Well, 5 times negative 2 is a negative 10, plus a negative 12 times 3 is a negative 36. And we add them up, you do get negative 46. So there's your solution. All right, number 3. Alright, so let's see what we get in number 3. Alright, so number 3 is going to be this one. We have 2x equal 9 plus 3y, and we have 4y equals 8 minus 3x. Alright, now, again, I would not use substitution here because you might say, well, I can get x by itself just by, in this case, dividing both sides by 2. Yes, you can, but you'd have 9 halves and you'd have 3 halves, so you'd have a fraction. And the same thing with y. I can get y by itself just by dividing both sides by 4. 8 divided by 4 is 2, but your fraction would be here, negative 3/4. So again, you don't want to do that. So the best thing to do is use the addition method. Now remember, when using the addition method, you have to have your equations in standard form. Okay, standard form. They must be in standard form. So all the variables on one side, constant to the other. All the variables on one side, constant to the other, and make sure your variables are aligned. So we got to rewrite this. So 2x. When I subtract 3y from both sides, that's what you got to do, subtract 3y. I get 2x minus 3y equal 9. Over here, I'm going to add 3x to both sides, so I get 3x plus 4y equal 8. So make sure you understand why this is positive 3x, because I'm adding 3x to both sides to bring the variables to the other side. Okay? Alright, so now let me just go ahead and rewrite this over. Oh, and by the way, since there's only one solution, this is a consistent system. So this system is consistent. Alright, so it's a consistent system. Okay. Alright, so meaning that, also meaning that if you were to graph them, they would intersect at that point. If you were to graph, the two lines would intersect at this point. Alright, so I'm just going ahead and rewrite this. So 2x minus 3y equal 9, and then 3x minus plus 4y equal 8. Okay, so let's use addition. So again, we've got to eliminate one of the variables. What I'm going to do now, and it does not matter, but what I'm going to do now is I notice that the y's, one's negative, one's positive. So I'm just going to go ahead and eliminate the y's. So let's eliminate y's. Alright, so the LCD of 3 and 4 is 12. Alright, so the LCD is 12. So I'm going to go ahead and write it again. Alright, now remember, so what's going to happen is that both of these are going to end up being 12s, but you want to be opposite. So one has to be a negative and one has to be a positive. So you already have your signs. So I don't need to multiply. Remember in the previous problem, I had to multiply. One of these had to be negative and one had to be positive. Here, they both can be positive. So if I need this to be a negative 12, then I got to multiply negative 3 by 4. So all this is going to be multiplied by 4. If I need this to be a positive 12, then I need to multiply 4 by 3. So all these have to be multiplied by 3. Okay? So then you distribute, and let's see what we get. So 4 times 2x is 8x. 4 times negative 3y is a negative 12y. Remember, that's what you wanted. Equal, don't forget this, that a lot of students forget the 9. 4 times 9 is 36, so you got to be careful. Over here, 3 times 3x is 9x. 3 times 4y is 12y. Equal, and then 3 times 28 is 24. Okay, now I can add these. When I add them, 9x and 8x is 17x. The y's add up to be 0. Equal, 36 plus 24 is 60, it looks like. Okay, 60. Now, dividing both sides by 17, I get x to be 60 divided by 17. Now, here's the situation we're in now. So notice that the coefficient, the solution, my ordered pair, the x coordinate is 60 divided by 17. That's a fraction. And if you were to, you might say, well, I'm just going ahead and write as a decimal. Yeah, well, look at this. If you write as a decimal, that's what you get. So it doesn't terminate. It just keeps on going. Okay, so you really don't want to write this as a decimal. You're not going to estimate this. You're not going to round this off, because then your y solution would not be exact. So then what you're going to have to do, and technically what we did before, remember, is we took 3 here, if you go back to the previous one, and in place of the variable, this was y, in place of the variable y, I plugged in 3. Now that wasn't too bad. That was pretty easy because that was an integer, and these were nice numbers. See how nice those numbers are? Well, just think what happens if you plug in a fraction, 60 over 17, and you can't reduce that, 60 over 17 in place of x here. You're going to be dealing with fractions. Alright, so here's the point I'm making. If you substitute 60 divided by 17 into one of the original equations, you're going to have to deal with fractions, and it could become very cumbersome for you. So remember a while ago we eliminated the y? Well, just eliminate the x. Go back and eliminate the x. It doesn't matter. So instead of eliminate the y, you eliminate the x. Remember when we did this, we had a choice? We had a choice. You could eliminate the x or the y. Well, we eliminate the y in first. Alright, since I ended up with a fraction, I don't want to deal with fractions. I don't want to substitute those fractions back into here. So since I have a fraction, and it's not a very nice fraction, eliminate the x. So use the addition method again. Eliminate the x. All right. So I'm going to go ahead and do this. Now I'm going to write this right here over. So I get 2x minus 3y equal 9. 3x plus 4y equal 8. All right. So all I did was I just rewrote the system, but this part here, not the original. I just rewrote the part where I brought all the I put them in standard form. Alright, now on my math lab there is one problem in which your coordinates are fractions. So it is a good idea, if the first one's a fraction, just go ahead and do elimination again with the other variable. Alright, so if I want to eliminate the x, I need this to be the LCD of 2 and 3 equals 6. But remember, they got to be opposites. So one of these has to be positive 6, the other has to be a negative 6. Okay, it does not matter which one. So what I'm going to do is I'm going to multiply this one by negative 3, and then multiply this by 2. Because negative 3 times 2x is negative 6x, 2 times 3x is 6x. Add them up, you get 0. But again, be careful, because you got to multiply every term on both sides by these numbers. So then I get negative 3 times 2x is negative 6x. Negative 3 times negative 3y is a positive 9y. Negative 3 times 9 is a negative 27. 2 times 3x is 6x. 2 times 4y is 8y. Equal, and then 2 times 8 is 16. And now I can add. These cancel out. You get 0. Negative 6x plus 6x is 0. 9y and 8y is 17y. Equal, and then a negative 27 and a positive 16 is a negative 11. And now dividing both sides by 17, just like this. 17 divided by 17 is 1. 1 times y is y. Your y coordinate is negative 11 over 17. Notice how easy it is just to go back and use elimination on the other variable rather than substituting this fraction. Alright. So don't forget, if you do end up with a fraction, just go ahead and do elimination on the other variable, and then you're going to get your answer. Okay, so that's negative 11 over 17. All right, so that takes care of that. And also, since there's just one solution, this is a consistent system. Consistent system. Okay. All right, let's look at number 4. You have 2x minus 3y equal 9, and then 6y equal 4x minus 18. Okay, I'm going to go ahead and I'm not going to use substitution. I'm going to use the addition method, but I need to go ahead and put those in standard form. The first equation is already in standard form. The second one is not. So I'm going to just go ahead and rewrite this, put it in standard form. 2x minus 3y equal 9. We've got to put it in standard form. Alright, so this is going to become, remember, I'm going to have to subtract 4x on both sides now. So that's a negative 4x plus 6y equal a negative 18. Now be careful, don't say 18, it's a negative 18. So you can easily mess up anywhere along the way, so you got to always double check your work. Okay, so I'm going to go ahead and eliminate the x. It does not matter. You could eliminate the y. It does not matter. So I got to find the LCD that I need. So the LCD of 2 and 4 is 8. But remember, I need one to be a positive 8, one to be a negative 8. Well, since the signs are different, all I'm going to do is just multiply both of these by positive numbers. So this 2x times 4 is going to give me the 8x that I need. And negative 4x times 2 is going to give me the negative 8x. Alright, so then I'm going to distribute, just like I've been doing before. No issue here. 4 times 2x is 8x. 4 times negative 3y is negative 12y. Equal, and then 4 times 9 is 36. The second equation. 2 times negative 4x is a negative 8x. 2 times 6y is 12y. And then 2 times negative 18 is a negative 36. Right, now adding them up. Now notice what happens when you add them up this time. Okay, so when you add them up, 8x minus 8x is 0. Negative 12y and a positive 12y is 0. 36 and a negative 36 is 0. So what you end up with now, make sure you understand this, 0 plus 0 is 0, equal. 36 minus 36 is 0. So you end up with the variables going away, so the variables disappearing, so to speak, and you end up with the statement z equals 0, and that's a true statement. Remember we talked about that before. True statement versus false statement. And so what that means is this, since the variable disappeared, remember the variable disappeared, going back to a lesson we learned earlier, if a variable disappears, you either get no solution or you get an infinite number of solutions. Okay? So true statement is where you get an infinite number of solutions. So there's an infinite number of solutions. Now, be careful. When we talked about in the previous one, remember in the previous lesson where we had an infinite number of solutions, that was our answer? So all real numbers was our answer. That was because your equation only had one variable. This equation has two variables, so your system. So there's two variables here. So you can't say, so it's infinite number solution, I'm going to go ahead and say that. But you can't say all ordered, remember we're talking about ordered pairs, so all ordered pairs is a solution. That's not true. Make sure you understand that when I say an infinite number of solutions, I am not talking about this. Every point in a plane is a solution. That's not true. Those are not all solutions. That's not what I'm saying. Remember, if you graph these lines, and I don't know what the lines are going to look like, but let's suppose that these are my lines right here. They overlap. So notice only the solutions that are here on this line are solutions. I'm sorry. Only the points on this line are solutions. None of these other points are solutions. So make sure you understand what I mean when I say the word infinite. Okay? There is an infinite number solution. This line, every point on that line, and there are an infinite number of points, is a solution. Not none of these, only these. Okay? Alright, so just make sure you understand that. Alright, now, since these are the only points that are solutions, and there's an infinite number, here's how you're going to write your answer. Okay, now before we go on, let me just mention that remember, we have at least one solution, right? There's an infinite. So this is a consistent system, but you say it's dependent. All right, so that's a dependent system. So use the word dependent instead. So this system is dependent. One equation depends on the other. They overlap. They coincide. All right, now here's how you write your solution. This is how you write the solution. Solutions must be written like this. So remember in the previously, here's how you wrote your solution. You wrote as an ordered pair. You wrote this as an ordered pair. You wrote this as an ordered pair. And the reason that's all you did was because there was only one solution. You're graphing two lines, so these three only had one solution. But the problem is this. You have an even number solution. There is no way you can list all of your solutions, all of these ordered pairs. You can't list them all. So here's how you're going to do it. You're going to say this. The solutions is the set. Let me write this a little bit better. The set, remember the set notation, is a set of coordinates x, y, set of coordinates x, y, such that, and guys, all you do is just use one of those equations. It does not matter which one. Let's just use the top one. Such that 2x minus 3y equals a 9. Right here, sorry. So the set of x, y, set of ordered pairs, such that 2x minus 3y, I just pick one of these equations. You could do the second one if you want to. It does not matter. Equal 9. All right. So there's an infinite number. Every point. Now, remember, I just made up this line. I don't know if it looks like this. I just made that up. But every ordered pair that satisfies this equation is going to be a solution. All right. Now, again, it doesn't mean that all of these are solutions. Only the points where the two lines overlap. Okay. All right. Now, let's look at number 5. All right, number 5, you have negative 4y equals 5x plus 7, and then 4y plus 5x equal 12. All right, so put this in, I'm going to write this in standard form. So I'm going to go ahead and rewrite this because you got to put it in standard form. And we're going to use the addition method. So I'm going to have to subtract 5x on both sides here. So I get negative 5x minus 4y equals 7. 5x plus 4y. Oh, remember, I rewrote this so that the 5x is first because remember you want to align your variables, your like terms. Align your like terms. Equal, and then that's 12. All right, now let's go ahead and eliminate the x. Eliminate the x. What you want you to notice here is there's really nothing to do because they're already opposites. Those x's are already opposites. Negative 5, positive 5, so I just add. That's all I do is just add. But notice what happens when I add. Negative 5x and 5x is 0. Negative 4y and 4y is 0. 0 plus 0 is 0. On the other side, 7 plus 12 is 19. Notice your variables disappear. So remember in the past, when we just dealt with linear equations in one variable, these are systems of linear equations in two variables. So in the past, when your variables disappeared, remember you only had, your answer would be either no solution or all real numbers. That was your answer. Here, this is a false statement. That's a false statement. So you're going to say there's no solution. So where it says solution and the blank, you're just going to put the empty set, or you say no solution. And that's all you do. All right. Now, so if there's no solution, remember we say that this is an inconsistent. This is an inconsistent. This is an inconsistent system. So you have no solution. Now what that means is this. It also means that the graphs, the two graphs, are, remember, no solution means they don't intersect. Well, if two lines don't intersect, then they have to be parallel. So it also means that two lines are parallel. They do not intersect. Do not intersect. So if they don't intersect, they have nothing. They have no solutions. Okay, so guys, that's going to take care of that part. So there are some MyMathLab problems that deal with what we just talked about. So this is part 4, and there's going to be a worksheet on that. So just use this to help you with the worksheet.